high-volume software engineering teams are checking their API logs. Many are cutting monthly inference costs from $2,800 down to $450, and they are achieving this cost reduction while simultaneously deploying autonomous parallel workflows of up to 300 coding agents. This pivot toward open-weights efficiency is driven by a newly released model called KEMI K2.6 for Moonshot AI. This model has recently bypassed proprietary giants like Claude Opus 4.6 and GPT 5.4 on top coding benchmarks. I'm Avais Aziz. Today, we are going to examine the benchmark data behind these claims and reveal how you can deploy this exact setup locally using a free Nvidia pathway. This chart displays the code categories arena data, measuring top-tier model proficiency. Kimi K2.6 sits at the absolute top, with an ELO rating of 1353. You can see how it performs relative to highly capable existing models like GLM 5.1, holding a distinct lead. In practical terms, that high score means the model succeeds at navigating complex, multi-step repository operations, tasks where older models typically fail and lose the pret. We will analyze the underlying architecture, explain the swarm scaling mechanics, and detail local Nvidia configuration steps. By removing the traditional cost barrier, KEMI K2.6 makes enterprise-level autonomous AI coding accessible for individual developers. This table compares key performance metrics across top models. Looking at the SWE-bench Pro data, KEMI K2.6 scores a 58.6, outperforming Claude Opus 4.6's 53.4. That percentage represents the state-of-the-art ability to hand the model a massive, messy legacy codebase and expect the functional refactoring. It executes these multi-file refactors without hallucinating variables or losing track of the logic halfway through the task. The hardware scale making this possible is a 1 trillion parameter network. It utilizes a mixture of experts architecture. During inference, it only activates a small, specialized part of the network, around 32 billion active parameters per token. This setup gives developers the deep reasoning capabilities of a massive system without the crippling computational overhead typically required to run it. Older models often collapse on extensive multi-file refactors because overarching context memory errors cause the logic to fragment. When KEMI hits an obstacle, it triggers an automatic self-correction loop. It reviews the error, adjusts its internal plan, and successfully completes the subsequent steps rather than failing it out entirely. The mixture of experts architecture solves the heavy computing cost barrier. You get top-tier logic combined with entry-level overhead. The model is built with a massive 256K token context window. A token context window acts as the active memory. It dictates how much code, text, and operational planning the model holds in its mind simultaneously. Adding 256K tokens prevents the model from forgetting its overarching instructions and generating disjointed, broken code over long tasks. Returning to the metrics table, this massive, stable, active memory is what enables the agent swarm capability. The swarm logic functions through a central coordinator node. It breaks down large repository tasks, distributing them to 300 parallel nodes. Because of this coordination, users report the system running DevOps tasks autonomously for 12 to 13 hours continuously. This capacity also extends to text, allowing the swarm to ingest and synthesize massive documents, like a 104-page literature review, in a single run. The system also integrates the MoonVT vision encoder, allowing the model to natively process multimodal inputs. That integrated vision encoder takes flat UI screenshots and directly converts them into structured front-end HTML and CSS. Developers can further optimize compute time by switching between distinct thinking and instant modes based on the complexity of the current task. If you find these deep architectural breakdowns useful, please leave a like on the video. Combining a 256K memory and a 300-agent swarm moves OpenAI away from simple single-prompt chatting and into true long-horizon software engineering. The most practical aspect of this trillion-parameter architecture is how accessible it is today. Nvidia is currently hosting KEMI K2.6 on their infrastructure, providing a free API endpoint for developer testing. They offer this through an OpenAI-compatible endpoint. This connection standard lets you instantly swap models inside your existing tools by simply changing a web address and an API key. You do not need to install any custom SDKs. It plugs directly into popular local IDE tools like Kilo, Root, client or open code. To connect it, point your tool's base URL to Nvidia's integrate API address. Then type the exact target model ID, Moonshot/KEMI K2.6, to finalize the connection. This specific local setup lets developers completely bypass the steep monthly costs of proprietary models, which can easily reach $2,800. As the data shows, you can run thousands of parallel API calls and full autonomous swarms for fractions of a penny. The single caveat is that this free endpoint is subject to Nvidia's ongoing developer testing terms, so availability may change over time. But right now, it provides a zero-risk sandbox environment. You can validate these advanced agent swarm capabilities directly on your own repositories. Subscribe to the channel to stay updated on critical technical architecture shifts like this one, and let me know in the comments, what specific coding task do you plan to test first with Kimi K2.6? Integrating KEMI K2.6 via Nvidia brings massive, scalable, autonomous engineering directly into your existing workflow, eliminating the traditional enterprise cost.